Hello everyone, welcome to the sixth lecture of this series, which is based on Naïve Bayes classifier, and we'll be demonstrating application of Naïve Bayes using Python. So it is a probabilistic classifier based on Bayes theorem with the assumption that features are conditionally independent given the class label. It is simple, efficient, and widely used for classification tasks like spam detection, sentiment analysis, and document classification. Here's the base theorem given. I have written it, just read it once. And now, what is naive assumption? The naive assumption is that all features are independent. This simplifies that computation of probability of x by c to probability of x by c and probability of x by c. It's given here, just see it. And now types of naive Bayes classifier. There are three types of classifiers: Gaussian, multinomial, and Bernoulli. So the first one is it assumes features are normally distributed. Multinomial is suitable for discrete features like word counts, and Bernoulli is suitable for binary or Boolean features. Now this is the code in Python. First, we begin by importing the necessary libraries. So as you can see, import train test split, Gaussian NB, accuracy score, confusion matrix, classification report, load iris. Here, let me explain these. Train test split, as you can see, the first is for splitting our dataset into training and testing parts. Gaussian NB is for naive Bayes classifier, which assumes the features follow a Gaussian distribution. We'll use accuracy score, confusion matrix, and classification report to evaluate the performance of our model. And load iris is used to load the iris dataset. Lastly, though we imported pandas, we don't be directly using it in this code. Now, second is loading the set. Loading the dataset. Here, the iris dataset contains 150 samples of flowers. Each sample has four features: sepal length, sepal width, petal, etc. X variable holds these features while Y contains the corresponding labels. Now splitting the data set. The data set is split into 70% of training and 30% is reserved for testing. So you can see the syntax. We have written test size is equal to 0.3 and initializing the model. Now we initialize the Gaussian naive Bayes classifier using the following code, which is model is equal to Gaussian NB, then bracket. Now training the model. Next we train the model using the fit model. So syntax is model.fit in bracket xtrain and ytrain. This trains the naive Bayes model using the training data. It learns the probability distribution of these features of each class. Now once trained, we use the model to make prediction on the test sets like this. Y prediction is equal to model.predict x test. Now let's evaluate our model's performance using matrix. Here's the code, which is accuracy is equal to accuracy underscore y test y prediction. Confusion matrix is equal to x test y test and report. Now print the accuracy, confusion matrix and classification report. The accuracy score gives us overall percentage of the correct prediction, and the confusion matrix tells us how many instances were correctly classified for each class and where the model got confused. The classification report provides detailed metrics like precision, recall, and F1 score for each of them. Here you have seen print the third display results, then example predictions. Now After running that code, you will see a result like this. Accuracy is 0.97%. Confusion matrix is that, and classification